2016, after 2 years of development, I released my own simulation software for research into molecule propagation. It's called Accord. You can freely download and run it right now, and I think it's a helpful research and learning tool for molecular communication. Here's how I came to build it and what it could be used for. In the early years of my PhD, I put together some basic molecule simulations to run in MATLAB software. These supported my early research into molecular communication, where a transmitter releases molecules observed by a receiver. But I was hitting limitations. There were two main problems. First, I had to directly modify the simulation code if I needed to make any changes to the system. This made it inefficient to test new variations, like including more than one transmitter. Second, the simulations were running too slowly. As a programming language, MATLAB is relatively easy to get something working, but it has inefficiencies that limit execution speed. I tried to find an existing simulator that I could switch to. The molecular communication research community had developed other simulators. However, these were either not publicly available, they were undocumented, or they were simple simulations with the same problems as my own code. I looked into the physical chemistry and multiphysics domains, where I found some great options, both open source and commercially licensed, but these weren't built for studying communication systems. For example, I needed to be able to repeat a random simulation many times to generate output statistics. Eventually, I decided to build a full simulator myself in the C programming language and almost entirely from scratch. I set out to build a simulation sandbox for molecular communication. The result was Accord, or actor-based communication via Reaction-Diffusion. Version 1.0 was released in late 2016. The journal paper describing it was published in 2017, and we've used it in other research too. So what does this simulator do? It models the randomness of molecule diffusion and chemical reactions. To use it, you define the geometry of your system, any locations where molecules are created, chemical reactions that the molecules can participate in, the times when molecules are added to the system, and when and where you make observations. The geometry is divided into regions, and you can mix and match how molecules are tracked in each region, either individually as particles or counting in compartments. We call these microscopic and mesoscopic approaches. You can have multiple types of molecules that all have their own properties like diffusion coefficients, reactions, and constant flow parameters. You can read the simulation output directly, or load it into MATLAB, where I also include utilities to help make a figure or create a video. Accord has been really helpful as a sandbox simulator that supports my research. Other research groups have used it too. Ongoing development is not as active as it used to be, but I'm still happy to support anyone using it, and my research group will work on future versions. It's important that we have accessible tools that lower the cost of entry in the field and make it easier to explore new systems, whether it's the layout of devices or the environment that they're in. Thanks for watching this micro abstract. If you liked it, let me know. If you really liked it and you want to see more on biophysical communication engineering, then you can subscribe and check out the other videos on the channel. See you next time.